Here we go. The last unit of the semester, Unit 6, Similarity. This is our test review. So you know the drill. Every page is going to be a separate video. So I think this one was 4 pages. So we should have 4 videos here. All right, so let's get to it. The ratio. The ratio of the sides of a triangle is 4 to 4 to 9. 4:4:9. All right. With the total perimeter of 200.6 feet. What are the measures of each side of the triangle? So I told you guys in class that 4 to 4 to 9. You can almost think of that as a fraction or a simplified ratio, simplified proportion. What I want you to do on something like this is I want you to think of it as 4x, and 9x. All right. So it's a triangle. All right. And it is a perimeter. What does perimeter mean? That's one of those things that, I would kind of expect you guys to remember. Perimeter is just the distance around the outside. If we had a triangular shaped track or something, how long would it take me to run around the outside? So we know the side lengths are in the proportion 4x to 4x to 9x. All right. So what I can do is I can just take all of those and I can add them together. 4x plus 4x plus 9x. All right, you add up all three of those sides, that is going to equal the perimeter, 200.6. All right. What does that give me? 8 plus 9, that's 17. 17x equals 200.6. Divide away the 17, and we're going to get some number. I have no idea what that is. 200.6. It's 11.8. It's 11.8. All right. So now also it says, what are the measures of each side of the triangle? How can we figure that? Plug them in. All right. So we would do 4 times 11.8. Right, then whatever that is, it's 47.2. All right. So both of these sides, 47.2. All right. And the other one is going to be 106.2. All right. And that one's done. Now the next one, they're telling us triangle A and G is similar. There's this symbol, that's kind of the new one here. It means similar. They are two similar triangles. A and G is similar to LES. So here's what I'm going to do. I'm going to draw two pictures and I'm going to label them A and G and LES. And then I'm going to fill in some blanks here. So we have LE. LE is a 7, ES is an 8, LS is 10, and NG is 12. Find the value of AG. All right, so we're looking for AG. So I want that piece right there. Now, when we have similar shapes, that means the sides are in proportion to one another. So there's a few different ways that you could set up this problem. What I like to do is I like to match up the corresponding sides. So X goes with 10. All right, those two match up. 12 matches up with 8. Those are corresponding sides. Think, okay, those are on the bottom of the triangle and the right side of the triangle. Or look at the order the letters are written. N and G, those are the last two letters in the first triangle. E and S, those are the last two letters in the second triangle. So those match up. So what we can do is we can make a proportion. Right? So we're going to say X divided by 10 equals 12 divided by 8. Let's just make sure we're going in the same order, right? I'm starting with the triangle on the left, and I'm finishing with the triangle on the right. And then I have to go in the same order. Now this is a proportion. What do? We cross multiply. All right, so I'm going to have 8x equals 120. All right, so x is going to equal something. I don't know what that is. 120 divided by 8 gives me 15. All right, and that one's done. Now the next one, the perimeter of similar triangles. So I have more similar triangles, so I'm going to draw two triangles. So I got ABC, and I have D, E, F. All right. So let's see the perimeters. So I'm going to say P equals 30 and P equals 25. Again, the perimeter is the distance around, and then it looks like they're telling us some side lengths. DE, where is DE? DE is 10. They want us to find AB. All right. So just like side lengths, perimeters also work with proportions. So I'm just going to do the same setup I did last time. I'm going to match up the sides. So I can say x over 10. Those are the corresponding sides. That is going to be proportional to the perimeters. So I have to go in the same order. So I will say 30 over 25. Right? The 30 is the perimeter of the triangle with the x in it. 25 is the perimeter of the triangle with a 10 in it. So cross multiply again. You have 30x. No, you don't. You have 25x. 25x equals 300. So I believe that's a 12. X should equal 12 there. All right. And there we have it. The next one, complementary angles, a unit 2 throwback to complementary angles. What does that mean? That means they equal 90 degrees. So here's what I'm going to do. I'm going to draw a picture that represents a 90-degree angle. All right, so that's what a 90-degree angle looks like. And I know there's two angles, so they have to add up to 90. So I'm just going to split this down the middle into two kind of separate angles. They're in the ratio 6 to 12. So again, call this 6x and 12x. All right, it's just a proportion. So we got 6x plus 12x equals, what does it equal? It equals 90 degrees. If I add up these two angles, they equal 90 degrees. So we have 18x equals 90. I want to say 5. Yeah, x equals 5. All right. So that one's done. I got one more here. I think I got one more. 3 more. All right. Determine. How can you determine which scale factors will result in a reduction versus an enlargement? All right. So scale factors, you multiply something. If I multiply a number, you give me any number. All right. So maybe x. X is my number. If you multiply this by something greater than 1, all right, so like a 2, a 4, a 20, whatever, that number is greater than 1, your final answer is going to be bigger than what you started with. If you multiply this by a number that's smaller than 1, like between 0 and 1, so maybe 1/2, or maybe 0.3, all right, that is going to make your final answer smaller. All right, so I'm not going to write anything down on this one. So if you're on mute, sorry. Any numbers that are bigger than 1 will be an enlargement. Any numbers between 0 and 1 will be a reduction. All right. Number 6, tell if the following triangles are similar. So there are 3 ways to tell that triangles are similar. There's the angle theorem. So if I have 2 triangles, if I have 2 angles, 2 corresponding angles that are congruent, those triangles are similar. I only need 2. I don't need that third one. I have the side angle side theorem that says if 2 sides are proportional and one angle between them is congruent, the triangles are similar. And then the last one is the side theorem, which basically says if I have 3 sides, corresponding sides, that are similar, then the triangles themselves are similar. So we have to check if the sides are proportional. I think I said similar down here. This should have been proportional. All right, so what does proportion mean? compare the sides. Which sides match up? What I like to do is I like to look at the triangle, think about the short, long, and kind of medium sides. All right, 4. 4 is the shortest side in that triangle. So what I have to do is I have to find the shortest side in the other triangle, which is 6. I will divide those two numbers. I'm going to say 4 divided by 6. All right. Now that's a fraction I can reduce down. Don't just type it in your calculator to get a decimal. Try to reduce it. All right. Divide them both by a 2. That is 2/3. All right. Now look at the biggest sides. All right. So 10, that's the biggest side in the left triangle. 15, that's the biggest side in the right triangle. Now divide those two numbers in the same order. All right, so I went small on top, the big ones on the bottom. So we have 10 divided by 15. And again, don't divide it in your calculator. Just reduce the fraction down. That is 2/3. All right. And then the last one, kind of the medium triangle, 8/12. 8/12. That is also dividing both by 4. You're going to have 2/3. All right. So what do you notice about those numbers? They are the same. So that means they are similar. How are they similar? This is the side similarity theorem. All right. So since they are similar, we can write a similarity statement. All right. So pick an order. I'm just going to go this direction. All right. So I'm going to go A, B, C. I have to go in the same direction on the other triangles. So what matches up with side length of 4? AB matched up with MN. If I'm going to go from A, B, and then B to C, I have to go in that same order. So I went from MN to NQ on this one. So the correct answer is MNQ. All right. And your scale factor. Your scale factor, there's a lot of ways you could write this. I would just stick to the simplified fraction. All right, so it's just 2/3. All right, it's 2/3. If you went the other direction, it would be 3/2. Okay, I'm not really specifying like what direction we're going. If I started with the first one, my scale factor should be 3/2 because it's getting bigger. All right, if I start with the triangle on the right and go to the one on the left, it should be 2/3 because it's getting smaller. So I'm not really specifying which direction we're going here. So either one of those answers would be acceptable in this situation. All right. The next one. This is no. And I'm going to tell you right off the bat it's no because the angle is in the wrong spot. All right. Remember, it's SAS. I said it, but I'm writing in the wrong stuff. SAS. Look where that angle is. The angle needs to be between the two sides. In this case, it's not. So this one, that's pretty quick that we can conclude that no, that one is not similar. Since it's not similar, there's no scale factor. Okay, so you would let's, I don't want to leave them blank. Let's put none. So I'm just going to put none. I'm going to put none. They're not similar. And then I'm going to put none. All right, they're not similar. There's no scale factor. And there's no theorem that says that they are similar. So that one is finished. All right, and actually that's the first page. So look at that, 1 down, 3 to go. So, I'll see you in the next one.